Hello everyone, welcome to my channel Math60 IIT Academy. So in this video we are going to solve the problems in the exercise 5.2, and here is a question: differentiate the functions with respect to x in the exercise 1 to 8. And here is our first question: sin x squared plus 5. Okay, so here treat this x squared plus 5 as x, then it will like sin x. So now differentiation of sin x, as we know here, it is a cos x. So cos, whatever we have treated as x, that function, given function, write as it is. So cos x squared plus 5, and now this x squared plus 5 differentiation we have to find. So now cos x squared plus 5, and now x squared plus 5 differentiation is 2x, and 5 of course constant, so here it will be 0. So this is answer for this. Next, second question: cos of sin x. Same, this function, let it be x here, then it will like cos x. So differentiation of this cos x is sin x, as we know here. So cos x differentiation minus sin x. Okay, and function of function derivative we have to find out. So here function of function is nothing but here sin x. So minus sine of sin x. Here differentiation of sin x is cos x. So here this is our answer. Next, question number 3: sine of ax plus b. So same here, let it be x. So sin x differentiation here cos x. So here it will become cos ax plus b, and now differentiation of this ax plus b we have to write. So now here cos ax plus b, and differentiation of ax is nothing but a, and b is a constant, so differentiation 0. So a into cos ax plus b is our solution for this. Next, question number 4 here: secant of tan of root x. So here we have 3 functions involving. So here from tan onwards we can consider this as one function x. So it will become what? Secant x. So now first write the differentiation of the secant x. So what is the secant x differentiation means here? Secant x tan x. So secant of x, right, we are saying. So we have treated this term as x. So write whatever the term which is given in place of x. So secant x means here we have tan of root x, secant x, tan x. So tan x means what here again? Tan root x. This is our given function. Okay, tan root x is our given function. Now function of function derivative we have to write. So here function of function is nothing but here tan of root x. Okay, so now up to this you have to write as it is until the final solution. So secant of tan root x, tan of tan root x. Now differentiation of tan root x. Here also we have 2 functions. One is tan x is one function, root x is another function. So you treat this root x as x, so it becomes tan x. So tan x differentiation we have to write. So tan x differentiation secant square x. So whatever the x we have, you write that. Now function of function derivative. So function of function in the sense here root x. So next step you write as it is secant of tan root x, tan of tan root x, secant square root x. Now root x differentiation we have to find. Root x differentiation is 1 by 2 root x. Okay, so this is a final answer. Okay, next question number 5. So here if you observe, numerator is sin ax plus b, denominator is cos ax plus d. So both the functions in terms of x are involving in numerator and denominator. So here we are going to use differentiation of u by v formula. So u by v dash is nothing but 1 by v square into vu dash minus uv dash. So take this numerator is u and this is v, and find the differentiation of this. So here v square means your denominator squared, so denominator is we have cos, so cos squared cx plus d. Here we are not doing differentiation, simply we are taking the square for the denominator. Here don't write the function of function derivative here, as we didn't differentiate here this, so simply we are writing just whole square. Okay, now you have to take this as a constant in the numerator first. Now so here cos cx plus d. Now numerator differentiation, so as we know here sin x differentiation is cos x, so take this ax plus b as x, so sin x differentiation is cos x, so here cos ax plus b, and this ax plus b differentiation we have to write, and its differentiation is a, minus here u means your numerator, write that as it is, so sin ax plus b, and here the differentiation of the denominator, that is cos x differentiation minus sin x, so that minus and this minus I am writing as plus here, so sin cx plus d, and here differentiation of this cx plus d we have to write here, and that is nothing but here c. Okay, so now if you rewrite this, what will happen, let us see. Here a I am writing as it is a constant, I am writing first, and now here cos cx plus d, and here cos ax plus b we have, and now here we have plus sign, and the c constant that I am writing first now, and here sin ax plus b and sin cx plus d. Okay, here denominator cos square cx plus d. Okay, so here what I am doing means here this cos square cx plus d I am writing for these two terms. Okay, sorry, there is a cursor problem, so that's why I am making some adjustment here. So here sin. Okay, fine. So here write this denominator for this term, so here cos square cx plus d, and for this term here cos square cx plus d. Okay, and now here when you look at these terms here, cos cx plus d, here we have one class cos cx plus d, term will get cancelled, and here also here we can write here right. So here sin cx plus d term we have here cos square cx plus d, so here with the same as functions here, so we can write this sin by cos as tan and 1 by cos as secant here. Okay, so now let us write whatever the terms we have in the next step. So here a is a constant that we have in the numerator, and cos ax plus b we have cos ax plus b, and in the denominator we have one more cos with the cx plus d as a term, and there is no such term in the numerator, so take this cos into the numerator, hence it will become a secant, so secant cx plus d plus here the constant is c. Now sin ax plus b, such term we don't have in the denominator, so write as it is here, so sin ax plus b, and sin here by cos, because here same angle we have here, so sin by cos is nothing but tan cx plus d, and 1 by cos is nothing but here secant, so secant cx plus d. So this, like this you can conclude the solution for the question number 5. And next we'll see the solution number 6 here. Question is cos x cube into sin square x power 5. So here we are going to solve this question by using the uv formula. So uv dash is equals to uv dash plus v into u dash. So you take this as first function u, and this is v, and then proceed, then you will get answer. Okay, so here uv dash is equals to, first I am taking this cos x cube as u, so that we have to maintain as constant in this step. So I am writing this cos x cube as it is. Now we have to differentiate the sine square x power 5. So as we can write the sine square x power 5 as sine x power 5 whole square. Sine x power 5 whole square we can write. So this is just like x square formula. So x square differentiation is nothing but 2x. So here the differentiation of sine square x power 5 will become 2 into sine x power 5. And now this differentiation of x power 5 we have to write. Okay, next plus. Now we should take this whatever the term we have differentiated here, that we have to take as constant. So sine square x power 5 will be the constant now in this case, into these unnecessary marks are coming, so please don't confuse here. Right. So sine square x power 5 we have taken as constant, and now cos x cube differentiation we have to write. So now cos, treat this x cube as x only. So cos x differentiation is minus sine x. So here minus sine x means here we have x cube, and this differentiation of x cube should be done here. And now you write the terms whatever we have a constant 2, so write in the front. So now cos x cube into sine x power 5, and here x power 5 differentiation 5 into x power 4, and here we have minus, plus becomes minus, and here sine square x power 5 sine x cube, and differentiation of this x cube will be equal to 3x square. Okay, so here multiply everything here. 5 into 2 10, constant I am writing first, even of course x term x power 4, and here we have cos x cube and sine x power 5 minus here 3x square sine square x power 5 and sine x cube. Okay, so this is the solution, and still you can continue by taking the terms which are common, but here no need, you can proceed as this is the final step. Okay, and next here we have another question 7. 2 into square root of cot x square. Okay, so here 2 is a constant of course, and root of this term which is involving in x we have. So take this term whatever we have under the square root as x here, so it will become what? Root x. So root x differentiation formula we have, that root x differentiation is 1 by 2 root x. So 1 by 2 root x. X means what here means here? The same function whatever it is given, that is cot x square. So this function of function derivative we have to write in the next step. So now this 2 and this 2 will get cancelled. So what we have means here square root of cot x square. Now differentiation of this cot x square. So cot x square means let it be this x square term as x. So cot x differentiation is minus cosecant square x. So minus cosecant square x means here x square. Now the function of function derivative should be done here, that is x square differentiation is 2x. Okay, so now here when you club all the here d by dx of x square. Okay, so d by dx of x square is 2x. So I am writing here as a final step, minus we have x square differentiation is 2x, and cosecant square x square divided by square root of cot x square. Okay, so this is our solution for question number 7. Next 8. So here solution we are going cos root x. Take root x as x, cos x differentiation minus sine x. So x means here what? Root x. So this differentiation we have to write in the next step. root x. So minus sine root x, differentiation of root x is 1 by 2 root x. Okay, so the final solution is minus sine root x by 2 root x. Okay, so this is the solution for question number 8. Next, 9. Prove that the function f given by f of x is equals to modulus of x minus 1, where x is real number, is not differentiable at x is equals to 1. Okay, so to prove this we have to use the first principle of the derivative. So here we have the formula. Here I am giving the formula. F dash of c is equals to limit h tends to 0 f of c plus h minus f of c divided by minus, of course, h. So here when we can say the function is differentiable means left hand derivative and also right hand derivative in the neighborhood of the point c exist and equal, then we can say the function is differentiable at the given point c. Okay, so here left hand derivative and also right hand derivative formula I am going to write here. So f dash of c, which is left hand, so left hand means here I am writing 0 minus. So now the formula will be here f of c minus h minus f of c divided by here minus h, and right hand derivative formula will be equal to f dash of c limit h tends to 0 plus, now because here right side, so just to know the difference here you have to write a 0 plus and here 0 minus, and here also the formula will be changed. So f of c plus h minus f of c divided by plus h. Okay, so these are the formulas of the left hand also right hand derivative. So at the point c, so when left hand derivative is equals to right hand derivative, then we can say differentiable, the function is differentiable at c. So here the question is about what, at the point 1 it is not differentiable, we have to show. So now find the first LHD means a left hand derivative, and then check the right hand derivative. If both are exist and also equal, then we could say here it is differentiable, otherwise not differentiable. So here given function is very clear, f of x is equals to modulus of x minus 1 and limit h tends to 0 minus f of here f dash of 1, because at point 1 we have to check, so take c is equals to 1. So f of 1 minus h minus f of 1 divided by minus h. So here f of 1 minus h value we have to write, so modulus of 1 minus h means here substitute here in place of x put 1 minus h, then you will get 1 minus h minus 1 minus f of 1 means here it will be 0, right? Simply substitute here 1 minus 1 will be 0 and divided by here minus h is there, and of course we have to write limit before this. So limit h tends to 0, that is a limit we have. So limit h tends to 0, here plus 1 and also minus 1 will cancel. Of course modulus of h is means here plus h by minus h, it will be equal to minus 1. And now we'll find the right hand derivative. So here right hand derivative will be, so right hand derivative f dash of 1 limit h tends to 0 here as well, and f of 1 plus h minus f of 1 divided by plus h. So now limit h tends to 0. Now as we have f of x is equals to modulus of x minus 1, simply to know f of 1 plus h value, in place of x substitute 1 plus h. So modulus of 1 plus h minus 1, of course f of 1 value will be 0, that we have written last time. Now this is will be h. Now again plus 1 minus 1 will be cancelled. Modulus of plus h is nothing but of course h. So here h by h, and this value will be what, here will be cancelled and will get 1. So here right hand derivative value is 1 and left hand derivative value is minus 1, hence here minus 1 is not equals to plus 1. So left hand derivative and right hand derivative are existing but they are not equal. So hence we could say this function is not differentiable at x is equals to 1. This is the proof. And next we have here question number 10. Prove that the greatest integer function defined by f of x is equals to greatest integer function x, where x is between 0 to 3, is not differentiable at x is equals to 1 and x is equals to 2. So of course, as we know here, what is the greatest integer function means here. Suppose here when you are taking here at 1 here, right hand derivative, of course left hand derivative we are going to check for this question as well. So when you are checking the right neighborhood of the 1 and right neighborhood of the 1 means let it be just like a 1.1. So this greatest integer value, so that means what, according to the definition, the least value of integer which is less than 1.1 is 1. Okay, so here when you see the left side, so here left neighborhood of 1 means here 0. Left neighborhood of 1 means here, suppose very nearest value to the 1. So when you are checking here, we are getting 0. Okay, so for 2 also we will follow the same. So here you see the solution, then you will understand. Limit h tends to 0 minus, first we are finding the left hand derivative. So f of c minus f of, first we are checking it 1. So 1 minus h minus f of 1 by minus h. So here f dash of 1 is equals to limit h tends to 0 1 minus h. So write as it is. Here the function f of x is mod greatest integer of x. So here greatest integer of 1 minus h minus f of 1. So greatest integer of 1. So divided by minus h. So here if you calculate this, limit h tends to 0, 1 minus h means here when you subtract a small positive arbitrary constant here from 1, obviously the value of this will be very close to 1. So let it be suppose 0.999. So whatever it is, so the integer which is very near and which is less than this will be equal to 0 minus 1 by, of course, minus h. Greatest integer of 1 is 1. So here minus and minus will cancel. Limit h tends to 0, 1 by h. Now when you are applying the limit here, as h tends to 0, 1 by h tends to infinity. So that means here it is not defined. So now next right hand derivative we have. So right hand derivative at 1 we are checking. So f dash of 1 which is equals to limit h tends to 0, f of 1 plus h minus f of 1 divided by plus h. So here limit h tends to 0, here 1 plus h means here greatest integer of 1 plus h minus 1 divided by plus h. So when you are adding a small positive arbitrary real number, let it be 1.1 suppose. So greatest integer of 1.1 will be equal to 1. So now limit h tends to 0, 1 minus 1 by h will be equal to 0. So now if you observe this, left hand derivative is infinity, right hand derivative is equal to 0. So left hand derivative and also right hand derivative are not equal here. So hence what we could say means here it is not differentiable at x is equals to 1. Now we will see the same thing at x is equals to 2 here. So left hand derivative, limit h tends to 0, f of 1, now 2 minus h we are checking, as we are checking here at 2. So c value is now is 2. So f of 2 minus h minus f of 2 divided by minus h. So limit h tends to 0, f of 2 minus h means here what we can write here 2 minus h minus f of 2 is 2 here. So divided by minus h. So now limit h tends to 0, 2 minus h means when you are subtracting one small positive quantity from 2, then it will be least to 1.99, very close to 2, but it is less than 2. So here 1.99 value. So 1.999 or something like this, then it will be equal to 1. So 1 minus greatest integer of 2 is 2 itself by minus h. 1 minus 2 is what here? Minus 1. So here minus 1 divided by minus h, it will become what here? Infinity. So left hand derivative at 2 means your f dash of 2 in the left side of 2 is infinity. Now right hand derivative will check at x is equals to, at c is equals to 2. So now h tends to 0, limit h tends to 0, f of 2 plus h minus f of 2 divided by plus h we have. So limit h tends to 0, 2 plus h, greatest integer of 2 plus h minus in greatest integer of 2 divided by plus h is equals to limit h tends to 0, 2 plus h means here 2.1 suppose. So here 2 minus 2 divided by here h, okay, denominator is h. So as we know here 2 minus 2 is 0, so right hand value is what here 0. So here you can clearly observe infinity is the left hand derivative and right hand derivative is a 0, so it will not be equal, so hence left hand derivative is not equal to right hand derivative. So this is not differentiable at x is equals to 2. Okay, so this is our exercise 5.2. So thank you for watching. Thank you all.